A very good morning, my dear students. Today we will summarize our chapter Powers and Exponents. So first of all, we will see that what is the definition. Definition says that if any rational number or any number is multiplying again and again, it means it is multiplying repeatedly. Like if x is a rational number and it is multiplying m times, that is x multiply x, how many times? M times, then it will be equal to x raised to the power m. It is known as power form or exponent form. Now in x raised to the power m, x is our base and m is known as exponent or power. For example, if 7 raised to the power 4, what will be the base? Base is 7 and power is 4. Now we will see that numbers with negative exponents, like if we have a number that has an exponent as negative, how it can be converted? For example, if I have a raised to the power minus m, then it can be written as 1 upon a raised to the power m. It will go in division. Or a raised to the power m can be written as 1 upon a raised to the power minus m. And here a should not be equal to 0. Now, a raised to the power minus m is the reciprocal of a raised to the power m. What is reciprocal? Reciprocal means you are dividing or you are flipping the number. So a raised to the power minus m is 1 upon a raised to the power m, and similarly a power m is the reciprocal of a raised to the power minus m. And if you multiply these two numbers, what will you get? You will get 1 as a answer. Now second part is, it is given that p upon q raised to the power minus m, and you have to convert this number into positive exponent. Here it is given that power is minus m and you have to convert into positive exponent. How will you convert? You will reverse the base, and power will be positive. For example, p by q is base. Now will reverse the base and the new base will be q by p and power will be m, only positive. Or if you have a number like p by q raised to the power m and you have to convert this number into negative exponent, then you will reverse the base will reverse q by p and power will become negative because it is given as positive. So note, if you have to change the sign of exponent, that is positive into negative or negative into positive, then you will reverse the base. You will reverse the base. Now, the another concept is to find the reciprocal of p by q whole power minus m. You are finding the reciprocal of p by q whole power minus m. How will you find? There are two ways. If first way is either change the base or keep the power as it is. It means p by q will be converted into q by p, reverse the base, and power minus m will as it is. So the reciprocal of p by q whole power minus m will be q by p whole power minus m. Or there is another way to do, how you will keep the base as it is. It means p by q, keep the base as it is and just change the power. Power will become now m. So if you have to find the reciprocal, then either reverse the base or change the power. Only one thing will change. You cannot change both things. It means you cannot simultaneously reverse the base and change the power. It is not the way to find the reciprocal. So in reciprocal, you will just change one thing. Now come to very important part of this chapter, laws of exponents. The following laws of exponents holds true when your base is any rational number and your power is any integer, maybe it positive, maybe it negative, maybe it zero. The first law says that x raised to the power m multiply x raised to the power n, it is equal to x raised to the power m plus n. It is known as product rule. So see here the structure. In left hand side you are multiplying two numbers and in right hand side you are getting only one number, and in left hand side powers are m and n, but your operation is multiplication. So in your final conclusion or in your right hand side, the power of the number will be added. The power of the number will be added and your base will remain same. It means x raised to the power m multiply x raised to the power n, it will give you x raised to the power m plus n. Now come to second law. Second law is quotient law or quotient rule. What it says, x raised to the power m divided by x raised to the power n. It means your operation is now division. Instead of multiplication, you are dividing two numbers and that two numbers have a same base x and their powers are different, that is m and n. So in this rule, what will you do? You will keep the base as it is. That means x, and now powers will be subtracted, because in case of division your powers will be subtracted. So your right hand side is x raised to the power m minus n. Now come to third rule. Third rule is power rule. Power is suggesting like if you have a number like x raised to the power m and whole power is n. You have a number x raised to the power m and whole power is n given, then what will you do? You will just multiply the powers. You will just multiply the powers and you will keep the base as it is. So your answer will be x raised to the power m multiply by n. Now come to fourth rule. Fourth rule is x raised to the power m multiply y raised to the power m. Now see here, base is x and y. Base are different in both of the numbers, but your power is same. Power is same in both numbers m. So finally it will give you x multiply y whole power m. See here, in left hand side you are multiplying two numbers that have different base but same power. So in right hand side you can combine these two numbers with multiplication and you will put the power as a common. It means you will put the power as x multiply y whole power will be m. Now the fifth rule is x raised to the power m divided by y raised to the power m. Here operation is of division and base are different x and y, but your power is still same. So what will you do in right hand side? You will keep the power as it is, m same power, but your numbers will be now x divided by y and whole power will be m. Whole power will be m. Now the sixth rule is, if any number that has a power of 0, like 2 raised to the power 0, 1 by 2 raised to the power 0, 5 raised to the power 0, it always gives you 1, except for x not equal to 0. That is, x cannot be equal to 0. Your base can't be equal to 0. Otherwise, any number that has a power of 0 it is equal to 1. Now, the another concept of your chapter is scientific notation. We did an activity related to scientific notation and we know very well that what is scientific notation. Now, the general form to represent any number in scientific notation is k multiplied by 10 raised to the power n. K multiply by 10 raised to the power n, where k is a number that is greater than or equal to 1 and less than 10. It means k can be 3.5, 7.4, 8.9, 9.3, but k cannot be equal to 10, and n is any integer. So if your number is greater than 1, if your number is greater than 1, then the power of 10, that is n will be positive. And if your number is smaller than 1, then your n will be negative. Now, students, there is one another concept, that is conversion of numbers into scientific notation. You already know what is scientific notation. Now we will convert our huge numbers or our small numbers into scientific notation so that it will be easy to read or write them. I am taking the examples that is greater than 1. For example, I have a number and its digits are 3, 4, 5, 6, 7. How many zeros are after 7? 5 zeros. So, what will you do? Your first step is first put the decimal point at last of the number. That is, after your last digit or after your last zero, you will put your decimal point. Now, step number 2. Put the decimal after first digit of the given number. What is the first digit in this example? 3. So you will put your decimal after 3. So how many decimals are there? 2 decimal. One is after 3 and one is after the last 0. Now step number 3 says that count the digits in between these two decimals. So you will count the digits. So how many digits are there in between these two decimals? I am counting and you have to count along with me. Count 1, 2, 3, 4, 5, 6, 7, 8, 9. How many is it digits? 9 digits. So step number 4 says the number of digits in between these decimals will be the power of 10. It means your value of n will be 9. Now step number 5. Step number 5 says that take the digits before 0 from your original number in the decimal form for the value of k. That is, you have to need or you need the two values k and n. Now n is found, that is 9, but for the value of k, what will be the value of k? K will be 3 point because you have put it the decimal after 3. So 3.4567. Stop here because after 7 there are only zeros. So you will write only non-zero digits. So k will be 3.4567. Now the scientific notation of this given number is 3.4567 multiplied by 10 raised to the power 9. Now we will do our conversion in the same manner but for the number that is smaller than 1. The number I am taking is 0.000005 zeros and then 87456. Now step number 1 is first put the decimal point after the first non-zero digit of the number. See, In your earlier example, there were no decimal point, but in these types of number, there is one decimal that is already given, that is 0 point. It means one decimal is given and you have to put one decimal more. That is, you need two decimals. So for another decimal, what will you do according to step number 1? Step number 1 is first put the decimal point after the first non-zero digit of the number. Non-zero digits are 8, 7, 4, 5, 6. First non-zero digit is 8. So you will put decimal after 8. Now step number 2. Count the number of digits in between these two decimals. So first decimal is your given and second decimal is your after 8. So how many digits are there? 1, 2, 3, 4, 5 and 6. 5 are zeros and 1 is 8. So how many digits are there in between these two decimals? 6 zeros. So step number 3 says that as the number is smaller than 1, the power of 10 will be negative. It means your value of n will be minus 6. Now step number 5. Take the digits after 0 from given number in decimal form for the value of k. It means you have to take the digits after zeros. After 5 zeros, how many digits are there? 8, 7, 4, 5, 6. So you need the value of k and you have put it the decimal after 8. So your value of k will become 8.7456. And finally, the scientific notation of this given number will be 8.7456 multiply by 10 raised to the power minus 6. So this is the conversion of numbers into scientific notation. Now, students, we will convert our scientific notation into usual form. In earlier two examples, what we did, we converted the numbers into scientific notation, and now we will convert the numbers as scientific notation into usual form. First, I am taking a number that is greater than 1, and if your number is greater than 1, then in scientific notation, will the power will be positive or negative? Remember, positive. So I am taking example as 2.456 multiply by 10 raised to the power 6. Now step number 1. First, remove the decimal point and write the number as it is. That is, you will remove the decimal after 2 and write the number 2456 as it is. Now, step number 2. Put the number of zeros equal to power of 10 after the number in step 1. That is, how many zeros are there? What is the power of 10? 6. So 6 zeros you have to put after 2, 4, 5, 6. So your number will be 2, 4, 5, 6 and 6 zeros. Now step number 3. Count the number of digits after decimal point in your given number. Your given number is 2.456 and how many digits are there after your decimal? 4, 5, 6. 3 digits are there. So step number 4 says that remove the number of zeros that is found in step 3 from the number written in step 2. It means you will remove how many zeros? 3 zeros from a number that is written in step 2. So your new number will be 2456000. So the usual form of 2.456 multiply by 10 raised to the power 6 will be 2456000. See how easy it is, the conversion. Now we will discuss the conversion of scientific notation into usual form for the numbers that are smaller than 1. And I told you that if your number is smaller than 1, then the power of 10 will be negative. So I am taking the example as 3.6785 multiplied by 10 raised to the power minus 5. Now step number 1, it says that first remove the decimal point and write the number as it is, that is 36785. Write it as it is. Now put the number of zeros equal to power of 10 before the number. Before the number. Why? Because your power of 10 is negative. So how many zeros are there? What is the power of 10? Negative 5. It means you will put 5 zeros before 36785. So your new number will be 0.000005 zeros and then 36785. Now step 3. Count the number of digits before your decimal point in the given number. Given number is 3.6785. How many digits before the number? See here, we are putting zeros or we are counting the digits before the decimal, and in earlier example that was a number greater than 1, we were doing all the things after the decimal. So this is the difference. So here before the decimal only one digit is there. So step number 3 says that count the number of digits before decimal point. Here the number of digits before decimal point is only 1. Now, step number 4. Remove the number of zeros that is founded in step number 3. How many digits are there? How many only one digit we have found. So it means we will remove only one zero from the number that is given in step number 2. So we will remove only one zero before this number. So the new number will be 0.0000036785. That is 4 zeros before 36785. So the usual form of 3.6785 multiplied by 10 raised to the power minus 5 is 0.00003685. Students, this was all about your 12th chapter powers and exponents from my side. Thank you.